Hello there, it's Lee Cassidy from Tactile Technology, and we've got another rerun for you from our Cloud Native event in July. This time it's myself and Ross Cooper-Smith talking about utilizing SQL Server in containers, and how also Tintry can help you be more granular with your SQL Server actually on a private cloud environment. So please enjoy. Remember, it's all recorded, so you won't be able to comment. If you want to access the videos directly, look for Tactile Technology or Lee Cassidy on YouTube, or search for myself on LinkedIn, and you should be able to see all the previous content as well. Thank you very much.
Good afternoon, Lee. I'm doing well. How about yourself?
Seem to have... Oh, I think I've muted this particular area. Let me just unmute myself. I was watching two different things at the same time. It was I was getting a bit of an echo, so I just muted this site while I was actually doing the stream for the actual keynote at the same time. Multitasking. So it's great to see you again, and hopefully a number of people are joining us today. So what I'm going to do is share my screen. So if I pick my screen, because I'm going to kick things off today. So we're going to talk about utilizing SQL Server in a container, and a lot of people don't know you can actually do this, but it is pretty straightforward. So what we're going to do first is talk about why you'd want to, because not everybody understands the benefits of utilizing SQL Server in a container. But let's do a little bit of history to start with. So SQL Server itself, version 1, was released on an operating system most people don't know these days, is OS2 back in 1989. So it's been around quite a long time. The current version is the 2019 version. So the actual from time it was released to now is 32 years. So that's quite a lot of time for a particular product to be still in existence and people using it. It's been very widely used, especially when people went through the development using the .NET framework for a lot of applications. So first iterations of web-based services on a Microsoft platform. And there's a very large base of users within the SME space or SMB space, depending on your terminology, that small to medium-sized organizations. If we look worldwide, there's around about 180,000 users of SQL Server worldwide. And even just in the UK, there's at least 14,000 organizations are actually using SQL Server for some kind of application, whether that's an ISV who've developed their application and selling that to their customers, or it's an ISV that's deployed a SaaS-based service using SQL Server at the back end, or organizations that have taken SQL Server and developed their own applications with it. So a very large base of it. So one thing that people might want to do, because of the volume of applications that are already out there utilizing SQL Server, is to migrate them to a cloud native service. So utilizing Azure or AWS or GCP to run that. At the moment, if you just wanted to take your existing application, if it was focused purely around Windows, you could only really move the virtual machines into something like EC2 or equivalent in Azure to do this. So it wouldn't give you some of the benefits of cloud native. But if you could actually move them into containers, it gives you an all new world of deployment and the ability to move between different cloud providers once it's been done as well. The other thing is people are trying to move towards an agile development model, and that's a big driver for this cloud native piece. So we can actually break the application into smaller chunks. We can actually develop faster on these using agile development models and actually move towards more of a CI/CD pipeline generation, some automation for a DevOps team or internal development team for this, so we can get it out quicker. But also, if we can use that existing knowledge around the actual database, SQL Server, that we've had because of so many developers have used this and worked with it over a long time. And if we've internally developed an application utilizing SQL Server, even better, we can retain that knowledge and utilize that knowledge in this move to a more agile development model. The other thing is we might want to provide better availability, so high availability, without having to build clusters in the traditional way that we would do within a SQL Server environment. Building out clusters is not an easy thing, and getting to work effectively is not easy. So having the ability to run them in pods within a Kubernetes environment that gives them automatic high availability, but also you can actually do cross-zone protection as well, gives another option. Also, one of the challenges always with SQL Server is when you come to patch time. You want to actually patch up your SQL Server. You don't really want to take your service offline to be able to do that. So the ability to patch a particular SQL Server within a pod while the others deliver service without loss of service to end users is another benefit. But the final thing might be you want to improve performance. And what we've seen from the testing we've done using a Diamante platform, using either on-premise infrastructure, so bare metal hardware and software, also utilizing Microsoft Azure, doing the same testing. What we've seen, we're getting around about 3 to 30 times performance. That depends on the application itself and how it's utilizing the SQL Server, but also the amount of instance of a SQL Server you're running at the background in the back end as well. What we see, especially in Azure environment, is around about 900,000 IOPS when we utilize Ultima and Spectra to actually deliver this. But that's not the only way we could do it. There are other ways. But one of the other things, instead of improving performance, because performance might not be an issue to you, what you could do is reduce the amount of resources required to deliver the same application with the same performance. So if you're getting a factor of 3 or 5 or 10 improvement in performance, if you actually move to newer infrastructure, you could actually reduce the infrastructure down and deliver the same performance with a third or a fifth of what you had before. But how would you do this? Firstly, we need to consider the architecture. So within Kubernetes, we have this terminology called a node, and we also have inside that the idea of a pod. So pods run inside nodes, and pod replicas run across different nodes. And the idea is these replicas communicate to make sure that the others are still alive and working, and checking the performance of them. So if one of the pods fails, the other one takes over the workload, and we use front-end load balancers to deliver that. But the other thing we're doing is, if we do have a loss, we're looking to spin that back up really quickly in the background automatically, so we've actually got it available again to us quite quickly afterwards. So our application can talk direct to the primary nodes or to the secondary nodes, depending on how we're actually configuring it, utilizing load balancers. So to deploy inside a container, first thing we need to do is create some form of storage. So in a traditional Kubernetes environment, we'd create a PV, a persistent volume, using the appropriate storage. So from a performance perspective, is it flash or a combination of flash and spinning disk? What we're looking at from an encryption perspective, do we need to encrypt that data as well? Do we need an encrypted storage component for that? The alternative also Tintry, which Ross is going to cover when I finish my little piece. The next thing is we need to create the deployment. And part of creating a deployment, you'll create a YAML file which describes what the actual deployment looks like. So all of the components, where they're delivered, all the objects and things, which will also include how many replicas we want. Do we want 1, 2, 4, 10 replicas running in the background? We also then will define the persistent volumes and the PVC, so the persistent volume claim, so how the application accesses that storage when we're actually get up and running. We'll also define an SA password for the actual SQL Server, because that's a common thing, and we'll actually define that within the Kubernetes environment, and we'll actually define it inside the YAML file as well. We'll also then set a mount path. So, are we mounting the actual database on, the PV storage, or are we mounting it against something else like a SMB3 mount point, potentially with a Tintry environment? And we'll also define the ports we're going to use to access the actual database. Now, we're using the existing 1433 ports, or we can use different ports depending on what we're trying to achieve. We'd also then define the load balancers, because if we've got multiple pods running, we need to ensure that the load balancers know where these pods are, and it can actually divert the actual work across those multiple pods to ensure we get a good balance of the workloads. And if one of the pods disappears, it's seamless to the end user. Then we need to connect to the instance to make sure it's up and running once it's loaded. And then finally, we need to verify failure and recovery capabilities. So intentionally stopping a particular pod to make sure that the others take over the workload. And then when we restart it, it comes back up again. So once we've gone through all those processes, we know that we've got a running container-based SQL Server instance, and we're getting all the benefits that we could have from the previous slide, where we've got agility, we've got cross-platform capabilities, we've also got the high availability that we want to do as well for one availability application, but secondary for patching capabilities as well. Well, now I'm going to hand over to Ross, and he's going to take over. So I'll stop sharing my screen and give that back to Ross.
Thank you, Lee. All right, let me share this. Make sure I've picked the correct screen. That should be showing up. Lovely. And there we go, one presentation. So I'm going to be taking over essentially where Lee left off. Lee's covered a lot of the advantages and the high-level strengths of why you might want to run SQL in a container and some of the benefits of that. One of the points in there was the decision of where that storage is going to persist for the SQL Server. And yes, you can use Kubernetes PV volumes. We've got something at Tintri, which I think is probably a little bit more interesting, certainly for larger or production environments. So I'm going to just talk a little bit about SQL integrated storage for Tintri, how this works with containers, physical SQL servers, virtual SQL servers, and why it's very, very different to the classic kind of storage you'd expect to be running for SQL. We need to start with really what is SQL integrated storage. This essentially is Tintri applying the technology we've patented and been delivering in enterprise for over a decade, that was developed for virtualization. We're now providing out directly to SQL databases. It integrates natively with SQL Server, no agent installations. We're talking directly to the server using the API. It allows a lot of automation of SQL, and it's really designed about just making life easier, like making it simpler to manage the databases, making it simpler to deliver services, both in production and in test dev. And the driver for developing this really was some of our team are former DBAs with 20+ years experience. And we're seeing a lot of customers for many years that are heavily virtualized. They're looking at containers now as well. And there's a common theme of issues with managing databases on modern shared infrastructure. Modern infrastructure, heavily virtualized. Whether you're running services on-premise, whether you're running in the cloud, you're effectively running your SQL on a shared resource. And that is going to be exactly the same when you move into the container world. When you're renting containers from a cloud, again, that underlying storage is a shared resource. And the issues it tends to lead to from the DBA point of view is DBAs really struggle to isolate storage performance problems because they don't have visibility down to the storage layer. They can see the database isn't performing well, or they can see complaints coming in. But if the problem is outside the database and outside the software, they just hit a brick wall. You can get slowdowns due to needing to protect the data, to dev test policies, to maintenance, and you've got to schedule these out of hours. And in an increasingly 24/7 world, there's challenges around scheduling that. There's difficulties in understanding and calculating ahead of time how much infrastructure do we need to support this database. The DBA team aren't infrastructure experts. The infrastructure team aren't database experts. How much do I need to deploy now? How much do we need for testing? How much do we need in the future as we scale? And that goes hand in hand with some of the challenges around performance. How do we make sure that as we scale this, we're not going to have issues on a shared platform like virtualization or containers, where a workload running on the same infrastructure is having negative impacts on our database? And there's a lot of waiting around of the DBA waiting for a response from infrastructure, waiting for a response from the cloud team. There's a lot of things they just can't tackle themselves. And there's similar issues on the flip side, on the infrastructure team's perspective. Well, they can't see what's going on within databases. They can only see the infrastructure side. They're well aware you can get bottlenecks, but they're looking at performance for the entire storage solution. They normally can't see whether that's having an impact on an individual workload like a database. Things like DevOps policies or test and dev. Again, the infrastructure team can assist to an extent, but they're dealing with a much broader scope. And these are all problems that essentially VMstore has been solving for many, many years with classic virtualized infrastructure. This is the only storage array that really was designed from the ground up for the virtual world. It was designed by the former VP of engineering from VMware. Every virtual machine on this storage solution has its own lane of traffic. It's essentially acting like a hypervisor for storage. So you don't get noisy neighbor issues. You get intelligent quality of service for each workload. We isolate every application from each other. Hugely successful in production environments. Today, this is running the public gaming cloud for Sega, including Sega's SQL servers powering that cloud service. It's running a private cloud for Accenture. It's being used by the BBC, by ITV, many, many, many brand name companies across the globe. In the UK, we've got everything from small private enterprises to large-scale NHS trusts and major universities. And the reason they're all using VMstore is because it gives them an advantage. One of the biggest benefits, and there's lots of aspects to this, but just in summary, it offloads an awful lot of work from your infrastructure and operations teams. It gives you a lot more flexibility of the business. It solves a lot of the real world problems that you have deploying these services. And it does almost all of this automatically without any tuning or configuration whatsoever. It's a very, very different approach. And it applies to a whole range of workloads. Standard virtualization and VDI is really where the product range started. Software development and DevOps has always been a real strength. You've got companies like Dropbox using VMstore to develop their software. We've got some of the world's biggest developers actually using us because we can streamline software development. And that really dovetails very nicely into what people are using containers and where containers are finding their strength. It's around developing software, developing new workloads. So let's get it back onto topic. How does this relate to databases? Well, at the end of the day, VMstore is a unique storage solution that was designed to handle virtual machines. And if you look under the covers of VMstore and VMware, and if you look at how a virtual machine is saved within a data store, well, it's a collection of files with some metadata about what the files are being managed by the hypervisor. And we developed a storage solution that was aware of those files. It understood what they meant, and it was able to manage and profile the workloads down to that granular level. And when you take a step back and look at something like SQL Server at a high level view, well, when that's on the storage, it's exactly the same. It's a collection of files with some metadata about the files being managed by the SQL management console and tools. So we took that technology we've been applying to virtual machines for years, and we applied it to the database. So we can now profile the individual files. You've got storage hardware that understands what a database is. And it's a big difference in how you provide storage into the infrastructure. The classic storage for databases and virtual machines is you provide a LUN from a storage solution, and within that LUN, you're basically hosting the drives and the volumes for either virtual machines or your data file. When VMstore came out a decade ago, it was completely unique because it took the virtual machine away from the LUN, and you could now manage it directly as a virtual machine. You simply provision virtual machines, and it solves all that contention. But today, databases are normally living within those VMs. So the next phase is we take the database out, and we've now got a storage solution that natively understands the database. In the console for VMstore, you don't manage virtual machines, you don't manage LUNs, you simply create a database in SQL Server, and it appears in our console. What it gives you is all of the benefits we've been delivering for years for virtualization at the database level. You can have multiple databases running on the same infrastructure they cannot compete with each other for performance and for resources. Every single one gets a fair share of the resource. We're profiling the requirements automatically. Everyone gets its own lane of traffic. Everyone gets guaranteed I/O. You can put manual controls around this, but also one of the beauties of the intelligent infrastructure from Tintri is that we are doing this automatically in real time. As soon as you spin up a new database, we are profiling it and we are protecting its performance. And we've got literally thousands of customers around the globe that can speak to just how well this works. Including, if you're interested, there's a case study from Sega. I think the quote from Sega when they transitioned their cloud and their database environment onto VMstore was overwhelmingly effective. The automated tools just solve their problems overnight, and there's a very nice case study from them. What you also get is real-time analytics at the database and the file level. So if you do get a trouble ticket come in, complaining an application has slowed down, complaining there's an issue, a DBA normally would be stuck. They're looking at the software and working with the software team. They're looking at the database. They can tell you if there's a problem within the architecture of the database. It's very difficult for them to know if there's a performance issue down to the storage level. With VMstore now, you go into the console and you can monitor the individual database. You can see in the hardware all the latency, the throughput, the IOPS for that database, even down to the individual data file, log file, the tempDB. You've got end-to-end visibility of all of this. You can see performance that's happening within the storage array itself. We can look at performance that's happening across the network. We can profile performance from the application. For the first time ever, you now have end-to-end visibility for each individual database, even on a heavily virtualized or containerized or consolidated platform. And it's worth just mentioning this works for physical SQL servers, this works for virtualized SQL servers, and it works for containerized SQL servers. Does not matter how you choose to manage your database. As Lee says, there's a lot of benefits to containers. Lee and his team were seeing significant performance benefits running SQL in a container. But this gives you an underlying storage platform that can deliver you benefits today, and it can carry on working with those same benefits in the future as you virtualize or containerize your SQL. There's a lot of benefits for software development or for testing, whether this is QA, patch testing, whether this is user acceptance testing, security testing, or just part of a normal development cycle. When the hardware understands databases, you're able to make a copy instantly. We've got a demo online of a 300 terabyte database where you need to run testing against that database. And normally you would need to provision more storage. If it's in the cloud, you're buying more storage from that cloud provider. You need to copy the database, which is going to take time and it's going to have an impact on performance. Then you need to mount that on the server. You need to grant access to the test team or the development team. There's a lot of steps. With SQL integrated storage, you can simply say, I'd like to take a snapshot of the database now, and I would like to clone it to this SQL server, please. We've got a demo of a 300 terabyte database being copied in 7 seconds flat. No work needed on the SQL side, no configuration needed. You just wait for the task to finish, you refresh the SQL console, and you can see a new database ready to test. And it's literally a pointer to a copy, a snapshot taken at that point in time. Doesn't take up any extra space. It's not needed to move any data. There's been no performance impact. It's running on the same infrastructure, so there's less costs. But because that's a new database, and because we're aware that it's being presented as a new database, that copy is isolated from the original systems. You can put as much stress workload as you like on that copy. It cannot slow down your production system. That's just inherent in the technology that we're using. So lots of benefits for software development. These capabilities are why we have some of the world's biggest software companies using VMstore for software development, as well as for production. It also means that if you want to automate your processes, it's far, far simpler. Because with conventional storage, yes, you can automate these tasks, but you have to understand every level. So you have to automate the connection into the storage solution. You have to understand LUNs and mapping and networking. You have to understand how to link that to SQL. You have to automate importing it, how to manage change, update. There are a lot of steps. You're talking days or weeks of work to build that process. With SQL integrated storage from Tintri, all of that automation is inherently done for you. The engineering team have done that as we built out the integration. You can use the API to simply say, copy this database to that server, go. It's a far simpler process. It's far less error prone. So for automation, there's some big, big benefits. And at the end of the day, what it delivers is a very different experience for managing storage for SQL. Visibility. And we're not just talking visibility for an infrastructure team, but we're also talking the DBA team, and they can talk the same language. If a database administrator says this database is running slowly, guess what? That's exactly what the infrastructure team are looking at. They're looking at a storage console that tells them this is the performance for this database. In real time, here's the historical performance over the last 12 months. So you can see, is there a performance problem today? Is there a change in behavior? That can be a common one. A very common type of support ticket is an organization getting complaints that an application is running slowly. And when you go and look at the data, you can see, well, hold on a second. Yes, it's running slowly, but it's running 10 times the work that it was last week. What changed at 3 o'clock on Friday afternoon? And knowing the time when the behavior changed, that's a different conversation within the team, because as soon as you've got a time when there's a change happened, you know what change went on. You know where there's been a patch, a software update, whether someone started a test running. It really cuts down on the troubleshooting time. And that means better productivity for the business. It means more consistent performance for the business. Self-service. You can use this to enable private clouds or self-service environments, because again, the provisioning is done as databases. It's done in terms that a DBA understands. You don't need to train them in storage terms. We've covered the analytics. It's part of visibility. Predictable performance. You can run as many workloads as you like on the same infrastructure, and you can guarantee consistent performance for every single one. Under the covers, what we're essentially doing with the storage is exactly what VMware, Hyper-V, KVM are doing with shared access to CPUs within the hypervisor hosts. We've taken that exact same approach and applied it to the storage. To this day, it's still unique to Tintri. There's nobody else doing that. I do not know why, because it has a just tremendous effect on being able to run multiple workloads in parallel on the same infrastructure and have absolute confidence that you're not going to have noisy neighbor issues, performance issues, anything like that. You've got all the control. You've got the ability to snapshot data for development. There's another benefit I've not touched on, which is data protection. Ransomware, encryption viruses are a huge threat today. One of the other benefits of storage that understands databases or virtual machines is that storage snapshots are now a really strong level of protection against those types of threats to your data and to the business. A storage snapshot is instant. It has no impact on performance, but that is now a secure copy of your database that is no longer in the data path. A virus on your estate cannot modify that. You can roll back to that or copy that database to another server in seconds. You don't need to move data. You don't need to restore. You're getting similar levels of protection to, say, a tape or a cloud backup, but where they take hours or weeks to restore, your recovery time is literally the time it takes to mount that database, a few seconds. And that essentially is the introduction to SQL integrated storage from Tintri. If there's any questions, I'll happily take them now in the chat, or
yeah, we've got a couple of questions.
Okay, we've got more than one question.
So the first one to both of us was, how can we do back up the databases? So if I kick off, if we're using a traditional PV in the environment within Kubernetes, you can snapshot a persistent volume. So if the database sits in a persistent volume, you can snapshot that, you can archive it, you can recover to that point in time. But it's the whole of the persistent volume at that point in time. If using the Tintri intelligent SQL Server capabilities, it's slightly different, a bit more granular. I'll let Ross cover that.
Yeah, there's a few ways that you can do it on our side. One of the recommended approaches is you would simply set a policy. You would set a policy that says that any SQL database created that matches this policy is always going to have a snapshot schedule applied. You would normally have something like a grandfather, father, son schedule. We can add replication in there as well. So you can literally say, right, every 15 minutes, I need a hardware snapshot of the database. I want to make sure that's protected. Very simple way to back it up in a very, very robust form. And again, there's a full API around this. You can automate this as well as using traditional tools, as Lee mentioned, in parallel. Schema changes to SQL Server instances, that would be outside the scope really for the Tintri side. We're essentially transparent to that side of things. So we don't need to affect the schema of the SQL Server. We're just basically providing that underlying storage, and SQL sees us as a normal resource. Lee, can you answer the schema question?
Yeah. So if it's running a container, you've got your GitHub access, so you can actually use either Ansible or something else to extract those changes and apply them to the container at any point in time, or you can actually use a YAML file to deploy them, depending on what you're trying to achieve at the time. So again, very similar to if you were in a standard Windows environment and you want to make changes to the schema on the SQL Server itself, you can do exactly the same using GitHub and a variety of different technologies to do that. Is that okay for you, Arya? That's great. Well, right, we've hit the end of our session. So now what we're doing is handing over to networking. So on the left-hand side, you can see networking. So if you want to click on networking, you can go in there, say join the networking session, and what it will do, it pair you up with someone to have a quick conversation on video. So you need to allow it to have access to your microphone and video, and then you can have a little chat with someone. So anybody who's at the event can join there. So everybody who's gone in there and click join, it'll pair you up with people so you can actually do a little bit of networking with your peers. And thanks for joining us for this session. Bye.
Thanks, Lee. Thanks, everybody.
Hopefully you enjoyed the recording from our Cloud Native event in July. Some great sessions and speakers at the event. We're going to continue throughout the week giving you new reruns from those events. Remember, you can't go to any of them directly unless you go to our YouTube channel, which you can find on YouTube under Tactile Technology or via Lee Cassidy. You can also access them through LinkedIn by searching for content by myself. All the posts will be on there, so you just look out for Lee Cassidy and you'll be able to find those. Also, you can follow us on both YouTube and LinkedIn to make sure you don't miss future content and also the other reruns that we're going to do. Thank you very much.